Okay, so yeah, like I was saying, there's a lot of reasons um, why you would want to use Docker for reproducible science. You can think of it kind of like a mixture between a virtual machine and a supercharged virtual environment, right? So when you think about installing Python dependencies or Conda packages, and inevitably you get this like horrible collision between the versions of the packages that you've installed. The idea of Docker is that you are installing things basically from scratch. So the gist is that you're getting a blank canvas for you to install whatever you want. You can install your own like C libraries and then your own Python libraries on top of those. The gist is that Docker is going to give you an environment that boots the same on your machine as on somebody else's machine, right? And this is obviously super desirable for scientific research projects, right? Where I'm going to write my analysis, it's going to load in data, perform some function on it, and output a data product, right? Having that be an atomic and reusable and consistent bundle of software is super, super awesome. The reason that I'm making a big deal about it today in particular is that as compute czars, Tony and I are thinking about mandating the use of Docker for environment management on the new machines. This is a way of keeping the machines super, super clean, running smoothly. We're never messing with, sudo apt-get upgrade CUDA drivers and shit like that. It's just like you sign on, you boot your Docker container. It does exactly what it says it's going to do on the box. And then when you're done, you spin down the Docker container and you're no longer using that space or those resources on the machine anymore. So I hope this is not sounding like an intimidating or burdensome thing to do. And I'm going to show you today, I hope that this is actually going to hopefully relieve a lot of the developmental and engineering burden of running stuff on the machine. Yeah. Just to preempt a question that I think will almost certainly emerge, all of those libraries and GPU drivers and everything like that are going to work perfectly inside of Docker, as though you were installing them in a brand new machine. I'm going to screen share. Oh, and like, yeah, I said this a little earlier, but if you are, oh yeah, sorry, Tony.
Oh yeah, I was just going to say the other thing that this gives us as a benefit is sort of like lightweight, like process management, right? We will then have visibility into like all of the jobs that are running on Rex if everyone's using Docker, because they're all managed the same system.
Yeah. One
of the challenges like running things on remote servers and stuff is allocating resources.
Yeah.
And
yeah.
So you can get through later, but like one thing I want to think about is like the software allow you to better quantify how much like memory things you're going to be using.
Yeah. So yeah, there's a few superpowers that it gives you. One of them is, again, Docker is not a virtual machine, right? So it's not running like a full independent operating system, but what it is doing is it is isolating hardware and software available inside of it. And so what you can do is say, like, what I'm running right now is going to require one GPU, right? The only GPU that's available is GPU 3 or something, and I don't want to have to like go into my code and index, like device equals, CUDA:3 everywhere I'm talking about my device. And so instead I'm going to say, like, when I'm instantiating my Docker container, I'm going to tell it there's only one GPU that you should see inside of this container, and it's GPU 3. And now it's going to be as though your code was running on a machine with one GPU. And it's, whatever the default port slot is, like you display :0 or something like that. You can see what's running. So I'll show this in a moment. This is a really nasty setup. I should have mirrored my screen or sat on that side, I guess. Yeah, I might move the switch sides if that's cool. Sorry. It's going to be fun to watch on the owl.
The projector, will it be wireless?
Yeah. Not so late. No, you're good. You're good. You're good.
Is there any room?
You're good. It won't. Well, we'll figure that out. Yeah, maybe we'll get like a smart one that has like a Chromecast or a Apple, play. So Okay, so I'm gonna, oh, the other thing that I want to mention, and I'll drop this into the Zoom chat, is that there is a new document in the, where is it? There we go. In the wiki under compute resources, I have explanations of how to set up a new machine for Docker and how to use it for reproducible science. So if you are doing this for yourself or you want some reminders on the stuff that we're going to cover today, because I'm going to be using this as a cheat sheet on my other monitor, you can always hit that up and it'll have the information. Okay, so how do we use Docker? I'm starting in a brand new empty directory. And the use case that we're going to work toward today is maybe doing a simple machine learning, like scikit-learn classification workload inside of Docker. So how do we tell Docker to build a new virtual machine for us? We're going to use something called the Docker file. So the Docker file is just a simple text file, and the contents of it are instructions to go from having nothing installed on a brand new machine. You could imagine like buying a server and it comes from the factory. What are the first steps that you do on it? And you're going to bring that machine all the way through to running the actual code that you want to run. So as an example, I'm going to use the from directive. Here, is this color scheme bad? I can change this if this is that better? Oh, yeah. Okay. So I'm going to use this from directive to talk about what the base image is that I want to use. So an image you can think of like a blueprint. So I'm going to say I want to use the Ubuntu version 20.04 image. There's a list of these that I'll discuss how you find images later. And now I have the opportunity to list instructions that I want to run in this brand new machine. So basically what I'm indicating here is I am buying a brand new server. It comes from the factory with Ubuntu 20.04 installed. Now, what are the things that I want to happen? So I can say run, touch hello world.txt, right? And then I'm going to say, when I run this blueprint, when I instantiate this blueprint, I want it to say hello world and echo that out to my calling script.
Effectively, the root user
I am the pseudo user inside of my container. Now, that doesn't have to be true, right? That's true if you get an Ubuntu machine, right? So the fact that I'm the root user in a default Ubuntu install means that I'm going to be the root user inside of here. So if I wanted, like I could inside of here, there's a footnote that has this that is not worth talking about, but like I could say, sudo touch hello world.txt, even though I don't have sudo access on Bleed, right? This will still work because inside of my container, I do have sudo access, right? Right. So you have total privileges, right? This is your machine, right?
So hold on, where's hello world coming from now?
So I'm going to create a file inside of here, inside of the.
Are you like in the home directory?
I think we're probably in the root directory of the machine. So what I could do is.
It doesn't really matter, right? Like,
it doesn't really matter.
you like create files and store them and say, well, we're going to put them in a relative location.
Exactly.
Right?
Exactly.
And you could run CD here.
I can do anything I want, right? So I could say,
It's like I'm in a shell.
Exactly. Yeah. Right. So I could say, whatever, like this, right? So I'm going to run this. So what there's a difference. I've given two different types of commands here. I've given run commands. So these are things that are going to run when I'm building my blueprint of my Docker image, right? And then I have this command. This is going to run when I execute that image, when I convert that blueprint into a house, right? So let me do that now. I'm going to build.
But hold on, like make a directory. It could happen in either.
It could happen, yeah. So you have to decide, is this going to be part of the blueprint or part of the house? So if
you use the same blueprint for multiple.
You could, yeah. So I mean, so one use case here is I want to let's say I have a tool that I'm going to use all the time. So I have like a photogrammetry tool that I'm going to use where every time I come home from vacation, I'm going to put all the photographs of a statue into this Docker container. It's going to convert it into a 3D model, and I want the 3D model to come out, right? So I would not put my photos in using a run command because the photos are going to be different every time I use this blueprint, right? I would use the run command to install my photogrammetry software, and then I'm going to use a command to access the photographs each time I come home with a new set of photos, right? So I'm going to reuse this image a bunch of times, instantiating it into a bunch of different containers. Is that nomenclature clear, or does that merit talking about more?
Yeah, I like thinking about these sort of like Docker file, makefile things is like everything above the command is sort of like you're writing it with a bash script, and then like the command itself is like when you type in, dot slash bash script dot sh and like passing flags. Like that's sort of the mapping in my mind of how to separate those two things. That
Yeah,
helps.
yeah, I like that mnemonic a lot.
Also,
There's
according to Stack Overflow, you can run it, you can have as many running as you want, you can only have one command.
yeah, there are a few caveats on that, but you can imagine this command being like, what do you want to do when you're done, right? I mean, basically everything that I say, there's going to be a bunch of caveats because ultimately Docker is not a virtual machine, and there's like all sorts of really naughty things that you can do. I'm going to show some very straightforward things that keep Docker like clean and easy to use. If you feel like going off-roading with me at some point, we can do the dirty stuff together. But
So why is there difference between run and CMD? If I understand it right, they would do the same thing.
so
If I would instead have a run there and afterwards a CMD empty space.
yeah, so let me show you the difference. So again, run commands are going to happen to the blueprint, right? So this is like, build a closet, build a bathroom, right? And I'm going to distribute that blueprint, right? And then when it's time to build that house, the command is where you're saying, I'm actually, I'm going to do things to this house in particular.
So
So-
I'm literally on the Stack Overflow thread about run versus command.
Yeah.
And I'm finding it very helpful, so I'll share one other tidbit I see here. I like this analogy a lot. They say the run command is where you install Python onto the machine. That's like your apt-get install Python in the run command. And you do that, and now your image comes with Python pre-built. And then your CMD command is like run a Python script.
Yeah, so let me maybe this is let me perhaps do this. So if I were to say, print time.time here, right? And I'm going to put that into like time.txt, right? And now I'm going to have let's do this. Python 3-c print. Oh, this isn't going to work. I need to import this time. Ugh. I shouldn't have done it this way. What's the Unix command for time? Is it just time?
Yes.
I can just do like that.
I think it's POD, time of day.
TOD.
Not that.
I'm getting oh, this is time. Is there like a this is no. There's a flag that I need to be using for there's like probably a formatting flag that I need to have. But
Or is it just pick a different thing, like not time, just like.
well, so what I want to illustrate is that the this is going to print the time that I build this container. That's right, that I build this image, right? The run command is going to happen during build time, right? Like when did you compile the blueprint? This is going to print the time of when I execute the container, right?
So you put like, if you put something lengthy in between, like a bunch of installs,
Yeah.
you'll see a pretty significant time.
You'll see a pretty significant time difference because after I'm done building this image, right, this command still hasn't run. This is only going to run when I tell Docker run this image, right? So I mean, keep in mind here, right? We're not creating a script that's going to run start to finish right now, right? We're creating an image, right? We're creating like a bundle of software, and we're going to then say, unpack that and run it, but we can say that any number of times, right?
It's like compiling a C file and then later down the line, so you actually run that C file.
Yeah, exactly. So if you put like the current time in your C file before you build it, right, it's going to be stuck at the time when you compile that. Yeah.
I'm sorry for really being stuck on this. But
No,
this feels fundamental.
Yeah.
Why is the CMD specified in this file and not something that like? I know you keep saying it's not a virtual machine, but the way I want to think about it is like, I'm going to create my Ubuntu environment. It's going to have Python installed. It's going to have Torch installed, et cetera, et cetera, et cetera. I'm now going to have this little bundled Ubuntu environment, and I'm going to have it run a dozen different commands depending on what I want to tell it to do.
Yeah, this is a great question. So I think that the way to think about Docker is these are cheap, right? So a virtual machine is really expensive, right? Like when you allocate RAM to a virtual machine, it's gone from your host machine. It's not available until your virtual machine turns off. Docker images are super cheap. They are basically as expensive as running the underlying code itself. There's no overhead, right? Asterisk, right? And so the way that I would think about using Docker is not creating a virtual environment that you can then put stuff into. I would think of it more like creating an environment for a particular code base or a particular purpose, right? So this image that we build now, the only thing it will ever do is print out the current time. I would never use this for a general purpose Ubuntu environment.
So for example, I have a conda environment on Dolores right now.
Yeah.
And sometimes I run that conda environment as a Jupyter notebook. Sometimes I run it as a script.
Yeah.
Sometimes I connect to it with PyCharm remotely. It's
Yeah.
the same environment.
Mhm.
Would you have, so if you wanted to make like a Docker file that created a Jupyter notebook and a Docker file that ran Python script A and a Docker file that ran Python script B, would those be two separate Docker files that shared 99% of the lines?
You skipped to my like chapter 7. So
Sorry, I'm
no, this is great. That's
I
an awesome
just still
question.
don't see what we're doing.
Yeah. Okay. So this is a great point. So the idea of an image, right? So here I'm using a base image called Ubuntu, right? And I'm saying I want you to, like, before I as a user even think about what I'm going to interact with, I want you to have done all of the steps involved in installing Ubuntu and configuring Ubuntu, right? I'm going to create now an image. I'm going to call the image, whatever it is. In fact, let's actually do what you're saying, because I think this is like probably exactly the lines that we are all going to write first, right? So I'm going to put a run in here because I want this to be part of the blueprint, right? I want to run this once, not every time I open Docker, right? I'm going to say run, I guess I can just do apt-get update, right? And I'm going to say run apt-get install Python 3 dev. And I'm going to say command
Conda or something
like Python 3. Right. I mean, for example, let's say I'm not going to install Python on the host machine. I'm just going to have a Docker container that has Python. So I'm going to say Docker build --tag. I'm going to call this image Jordan's Python. And I'm going to specify that it should build the Docker file from the current directory. When I do this, it's going to download the base image. It's going to run all the steps. So here it's running like apt-get update inside of my new image, right? And whoops, I forgot. I'll pretend that this was part of my lesson plan. I forgot to specify that there's like a -y that I should put in.
Yeah,
there,
-y.
right?
Yeah.
Right.
User interpret, that doesn't happen.
Is it
Right.
always just like no extension Docker file?
Correct. Yeah. The file is just called Docker file like this. Okay, so there was an error in my Docker file. Oh gosh. So what I'm going to go in here and do is say sudo apt-get install -y, right? Okay, so this is actually a really nice opportunity to say, like, because Docker files are Docker images are immutable, right? Docker knows that because this line didn't change since the last time I built it, and this line didn't change since the last time I built it, it doesn't have to run those again, right? The first line that has changed is this. So the only line that this is going to run when I build this again is this line.
Is that cache shared amongst users, or is that like within the directory?
So that cache is shared among users, but if there's nothing here that could change between users, right? This is totally immutable. Now, if you have a line that says, like, copy in files from my home directory, that means that, Docker has to assume that nothing beyond that is cached. So I'm going to rebuild this Docker build. Right, this time it works, but you see that it didn't run the sudo apt-get update there. It just ran Python installation, right? It was smart enough to realize that it didn't have to run those steps again. Okay, so I've now, in the process of doing this Docker build command, I've created the blueprint, right? I can now say, well, let me first say Docker images, right? And I can see a list of all the images that have been installed on this machine, right? Now I'm going to say Docker run interactively Jordan's Python. And that command, that last line of the Docker file, that command is going to run when I tell it to instantiate this. Okay, so now I'm inside of Python. This Python is not installed on the host machine, right? This Python only exists in my Docker container. And as soon as I quit here, in fact, let me open up just to illustrate. I'm going to do Docker PS to show the currently running containers. You can see there's only one container running, right? When I exit out of Python over here, right, because that was the command, that was the last thing in my Docker file, I'm no longer in Docker here, right? I'm in my like real life actual host machine again. And if I do Docker PS again, you'll see that that image is that container's no longer.
I remember like live interactively with the Docker environment.
Yeah. So I can
I thought it
do,
was more like you can basically put everything in there, somebody just said like run it and then they get out whatever they need to or something like that.
you can, I mean, so the way that Docker images are currently used is like one-off things like that, where you'll instantiate a container and then let it,
Crap.
yeah, exactly. And then it'll go away when it's done. But you can run things interactively. And so one thing that, I would, you can decide if this is right for your use case, but I'm going to say like, Docker run -it Jordan's Python. And then instead of running Python, I'll say like, run Python -m http.server, right? So what I'm doing here is I'm overriding the command that I put at the end of my Docker file with a new thing that I want to run inside of this machine. Yeah, exactly, right. And so now I'm running, an HTTP server inside of there. I can't get to that. So if I,
like, there's got to be some. Like,
there's port,
Yeah,
there's
you
port
gotta open
right?
ports. Yeah.
And so if I do this and I go to, what is it, 8,000 by default, right? What was it, 8888? No, it's 8,000. Yeah. So if I go here, right, like it's not turned on, right? There's no way for me to get in there. But of course, this is like, Docker has thought of this problem, and I can activate that port by saying, let me go here, -p 8,000. So connect the port 8,000 on the host machine to the internal facing port 8,000, right? I could also say, for example, just to illustrate, and let me know if I'm overloading the demo here, but I can also say I want the host port 9,000 to point to internal port 8,000.
Is this how you would get access to a Jupyter
Yeah. So you could say,
server?
Yes.
I'm going to run a Jupyter server, right? And I want to connect my internal port 8888 to external 8888, right? And then I can access it in the browser. Right?
That notebook would be. If you, okay, sorry.
Yeah, no, this is,
you keep doing
what you're about to say is, okay, so let me, instead of running Python 3, I'm gonna run bash. Okay, I'm in my image, so I have Python installed, right? Now when I quit Python, I'm still inside of my Docker image because I'm running bash as the parent command, right? Let me do this. I'm going to say touch, hello, Kording Lab.txt. So if I ls, I have this hello Kording Lab.txt, right? I am in root, right? Yeah, right. When I exit this Docker container, right, I do not have that file here. I do not have that file here, right? That was ephemeral. It is gone, right? It's gone forever, right? It's actually not gone forever. It's still there, but
If you do that Docker again, is that how it's on?
yes, because remember, this happened in the house, not in the blueprint, right? So I ran this command inside of one house, so there's no reason for any other house to have it.
I'm gonna lose so many files. I give
So-
it to you.
So let me show you what.
I can just see it happening.
Yeah, let me show you what I would recommend, because this is like, there's a lot of moving parts here, right? And again, like, the purpose here is to like empower you to have the option to say, I don't care about my like data byproduct. All I want is like, the things that I actually want to save. Conversely, you could say like, I need everything that I'm going to write inside of this container. So let me do this. I'm going to say Docker run, and I'm going to run bash in my Python container for whatever reason. I'm going to use the -v to mount a volume that says the current directory slash data outputs should be mounted to inside the container, the directory called data outputs. Let's say now I'm going to run bash. Right. So now when I ls, again, I don't have that hello Kording Lab.txt from before. But if I say, for example, touch data outputs slash, hey, hello klab, just to illustrate this as a new file, right? And then I quit my Docker container. I have this data outputs file because I told Docker I wanted to put it there. And if I look inside of it, I have the file that I created inside of the Docker container.
Is there danger of simultaneously rewrites from outside and inside the container on the same file?
No. So there's no more or less danger than having like two shells open, reading and writing to. So you're going to get the same race conditions that you get as though you were running, bash on your actual machine. Because the fact is, you like under the hood, you are running bash on your actual machine.
So is there an automatic way? So oftentimes when I start a bash, I will put in a whole bunch of commands that kind of set up my environment.
Yeah.
Is there a way of taking like the history file of the bash and making it automatically into a Docker file?
There is, I mean, the easiest way to do this is that like you just prefix every line of your history with run, and you just like pop that into a Docker file, right? You know, some of that stuff will depend upon your like current local configuration and stuff like that. And I find that like converting a project into putting it in a Docker file gives me the opportunity to kind of meditate on like what here is actually immutable and what here have I been assuming is immutable but isn't really, right? Like if you assume that there will be a file in your home directory called like, you know, Conrad's secret password.txt, right? And that's not actually a fundamental truth about an Ubuntu machine, right? You have to explicitly annotate that and say, I like explicitly need that to be in my blueprint for my new Docker image.
So but what about this having to grapple with things like, and that might be because I'm less experienced, but when I install packages, I often get like error messages, have to do it again, and somehow like I need to put the install command twice to actually make it happen.
Yeah, yeah.
And pip install, like all kinds of like, there's so much ugly stuff that happens in installation. Maybe that's just with me.
Well, no, I think that that's universal. And one thing, you know, okay, so on the one hand, you suffer through it once and you build the image and now you have that image that it'll always work, right?
So then your file has like basically then 2 lines that I say.
It might.
Run pip install this and then run again,
Right.
install this.
The other thing to remember is that like when you build
like,
it,
pip tells you those things. It's like, please
like
run me
rerun
again.
this. Yeah. I mean, what I frequently find myself doing is I'm saying like, it's ridiculous that I'm spending all this time installing scikit-learn. Surely somebody has built a Docker image with scikit-learn in it before. And you can go to what's called Docker Hub.
You can download other
Yeah.
people's like, that is
There's an
Yeah.
official PyTorch document.
Yeah, exactly. And like you'll find that there's an official image for many things. Sorry, Tony. Yeah, I saw you had your hand up.
Actually, folks landed exactly on what I was gonna say. I was gonna say like this sort of thing where like not only can we pull predefined images from Docker Hub, like we could even build like a K-Lab specific Docker image that like, you know, master students download this Docker image and it has everything that you'll need to run, you know, the Leap-based project or everything to run, you know, Jordan's project. And we don't have to worry about doing that for each person onboarding. Yeah.
Exactly.
The class MTA has the Docker image for like the software. To make that up a lot easier. But yeah, I was gonna ask, is it like how might we migrate from a common package?
Yeah. Yeah. I mean, okay, so the easiest thing you can do, right, is say like, look, I'm gonna like, I feel comfortable with Conda. I'm gonna put Conda inside of my Docker environment. It has sudo, it can overwrite, you know, global directories if it wants to. It can do anything it wants because it's going to be inside of it, right? So you could choose to still use Conda. One thing that we could say,
Install it and then don't worry with my configuration.
right, and like Tony was saying, right, we have, you know, if I look at Docker images right now, I have this thing called Jordan's Python in here, right? In my new, let me make a directory called like, I don't know, Jupyter, right? And if I go in here and I make a new Docker file, right, I can say, you know, from Jordan's Python, and now I'm going to, so this could, you know, equivalently be, you know, from Kording Lab, you know, Julia for all of our Julia projects. And that way there's nothing installed except for the bare necessities for Julia. Yeah, sorry, Richard, you had your hand up.
Yeah, thing that you're certainly going to get to. My next question is going to be, what CPU and GPU devices are visible to inside of that?
Yeah, okay, so here what I've done is I've said, I've put in a command that I think is probably going to be the command that almost all of us run almost all of the time, right? Or something quite similar to it. I'm using from Docker Hub this Jupyter/data science notebook image, right? Which by default runs a Jupyter notebook server. I told it I want you to connect my port 8888 to the container's port 8888, and I want it to have access to all of my GPUs, right? I could equivalently say I want it to have access to, like, I don't remember how this works, but like, you know, 1 and 3 or something like that. Right. I don't remember precisely the notation for that, but I will make sure that all of this is available and probably maybe in our home directories by default on Rex. Right. And when I do this, it's going to spin up, you know, what it's doing here is it's downloading that base image from Docker Hub, right? Which, you know, this one I'm just looking in like this one happens to be vetted, but like also be careful because like certainly it's not unreasonable for somebody to put out like an open source project that is a little nefarious. Like
Is that community between? Wikis and-
it is on the wiki, yeah. I will share that. Yeah.
So how does this work across operating systems? Like if I'm on Windows, can I use Docker created from Linux?
Yeah, so Docker heavily uses Linux operating system features. Blah 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 implementation controls. Ultimately, the only thing that you need to know is that if you can install Docker, any Docker image will work. So there's Docker for desktop for Windows, for Mac. By default, it runs on Linux.
But in
Yeah.
that search page, you
Yeah.
can choose if you want Windows or Mac. Why
Yeah, I
why
wonder.
does it make it different?
I wonder if there's a way to have Windows container, Windows images. I believe that there was some research into this. It is possible. I think it's probably.
Windows inside of a.
Oh no, it totally works. Yeah. Sorry, you're totally right.
Why would
What was the
you
question?
do that?
That you can have a Windows container. Well, so you're on a Mac and you want to run
SolidWorks?
SolidWorks.
Oh,
Right.
okay.
Now, I mean, if that was the case, I would actually go in here and I would say, like, is there like a SolidWorks, image that I can use by default? Here, oh yeah, so here you're seeing you're seeing our Bleen GPU troubles manifest. Okay, but this is actually kind of nice because I can say like, okay, let me actually.
Can you keep that server up?
It's that third. Yeah. Let's see. Tony, you don't remember off the top of your head how to tell I only want one GPU, do you?
Tell how you want what?
I want just one GPU by number.
I think it's GPUs with an S, right?
Yeah. Is it this then?
I think, yeah,
Just one?
there you go. There you go.
Ah, super cool. Now.
Oh, no, oh, we never.
So, okay, this is maybe another opportunity for us to like, hey, look, there's a janky GPU on Bleen right now. It ruins it. Like every time you type NVIDIA SMI, right, it breaks everything. I'm not gonna Google documentation and notation while we're all sitting here together, but like ostensibly you can make a Docker container that only has access to the first 3 GPUs. As far as that container is concerned, that is like, all that is available in the universe. And so when you run Docker, NVIDIA SMI inside of that container, ostensibly it's going to run nicely because it doesn't even know about that bulk GPU. What do you?
I was trying to see if I could open the same port as you at the same time.
Oh, no. So
But I got a different error message.
permission denied when trying to connect to the Docker daemon. Oh, this is a Docker installation configuration thing. We need to add. Well, I'll work with you on that separately. That's a user groups thing.
I just sent the command for specifying specific GPUs. So you need to wrap device equals with single quotes. And you can tell.
Oh, okay.
Yeah.
You're saying
It's in the Zoom chat. If you want to just copy paste that.
I can't do that. You're saying like device like that? I'm not gonna. This is silly, but
Yeah,
everybody
yeah,
imagine.
correct. Yeah, it's something like that. But yeah, we'll do that later.
Yeah. All right. Yeah. We can worry about it.
Question.
Yeah.
So if I create like a new Docker file it will use the default CUDA is installed in our system, or I need to like install new CUDA.
So there is a Docker specific interface for GPUs. You can tell it, I want you to use the CUDA that's installed on the machine. I believe that you can also tell it, I want you to use CUDA 9 or something like that. And I believe that Docker will handle that for you.
So another question would be, can I interact with Docker via platforms like VS Code or Python?
Yes. So the other, and this, I have some code in this that I need to still verify will work on Rex because of our VPN, but in the same way that you can connect to a server using VS Code or PyCharm or whatever and run code, run your remote editing inside of like one of our servers, there's also a way for you to like connect VS Code or PyCharm to a container that's running on the machine. And what that does is you can say like, I want you to mount my home directory, but I want to have all custom Python, for this editing session. And you can treat that basically like its own machine that you're connecting to.
Yeah, when you're in PyCharm, when you go to add an interpreter, there's just a Docker option.
Yeah, it's super straightforward. And the other thing is that,
That's quite nice.
you know, as compute czars, Tony and I, and I'm volunteering you for this right now. We'll answer your questions and help you like build your Docker images and get things ready to go. I mean, I think that one of the things that's really nice about this is that if you, like I, have ever had the experience of like configuring a Conda environment or a Python virtual environment or whatever, and by the time you're done and you can actually run your code, you've like just decimated your entire system. Like you have like hard-coded aliases to Python 2 in your bash RC and like all sorts of like really terrible, you've overwritten installed binaries and stuff like that. The nice thing about running inside of Docker is that when you're done with that project, or if you're just done for the day and you close that container, you're back to this pristine, brand new, shiny, wonderful, fast machine. And there's no, when we, in fact, there's even a way for us to say, hey, we're going to, take the Rex server down for maintenance or whatever, and we pause all of the running Docker containers, right? Serialize them to disk, pull down the machine, bring it back up, and then rehydrate all of the containers, and nobody even notices that it was down, except if you were like a task at the time. It's a really, really powerful way of abstracting away a lot of the hardware from the software. Yeah, it's really, really cool stuff. You can do development. Oh, this is the other thing, right? You can do development, right? You build your Docker file on your laptop, right? Sitting on the airplane with no internet. And then when you connect, you say, I'm just going to move that Docker file, this tiny little text file, I'm going to move over to Dolores, and I'm going to rehydrate it there and build my image there. And it'll be just as good as if you had built it there to start, right? Those things are guaranteed to run exactly the same. The beauty of Docker. And again, these are lightweight, so you could run, a few 100,000 Docker images, containers on the same machine. And if you could run 100,000, Python kernels, you can run 100,000 too. Yeah.
A couple weeks ago, when this came up, or when Rex first arrived, and we were talking about this, we also had a conversation about resource management.
Yeah.
What happens? Okay, first question: what does resource management look like?
Mm-hmm.
More specific question, like if everyone in the lab tries to spin up 1,000 Docker containers at once, all using all the CPUs, what happens to the server?
So it'll, by default, it'll be the same thing as though all of us had SSH'd in and tried to use all the GPUs in real life.
So this is not by itself a resource.
It will not allocate resources and reserve them. Now, we can configure it to do that. I don't think we've ever really encountered a case where we needed to do that. I think usually, if I go to Lean,
I've heard Lean a few times over the summer just
by overloading.
Yes.
But it wasn't like somebody else was like waiting in line and they were like, oh no, I'm running and you've already got all the CPUs checking. I mean, like, the thing is like when I go to, but like when I go to Lean, right, and I'm going to run a Docker image, it's, it's still reasonably prudent for me to pop open HTOP, pop open NVIDIA SMI and see what's running. Now, if the lab thinks, as a community that it makes sense for us to do resource allocation and job queuing and job scheduling and stuff like that, we can do it. It's not terribly hard to set up. I think that my hesitance here is like, that's just an awful lot of logistics and configuration for like a problem that we don't usually have, especially considering that we are increasing the size of our compute. So
Okay.
I mean, yeah, I would be happy to talk about it. I mean, there are like really cool things like Slurm, right?
We talked about like networking the machines together.
Yeah. So this is my hope would be, and this is maybe in the last few minutes we can switch to philosophical discussions about compute clusters. But like, one thing that I'd like to consider doing is networking all of our machines together so that your user home directory and everything is persisted across all of the machines, right? It doesn't matter who you SSH into, you're still going to have all your files and your environments and your Docker images and everything. The other component of this that I'd like to do is a little spring cleaning and progressively take one machine offline and wipe it entirely and then put it back up online with the latest OS, latest CUDA drivers, and hopefully also with this Docker style mentality. So what I'd like to do is maybe do like a 2 or 3 month warning on a machine. We can pick which one, right? And say like, get your files off of here and then anything that's left, we will drop to cold storage and maybe put in like Amazon Deep Glacier. So it's going to cost us like $1 a year to hold a few terabytes of user directories that no one uses anymore. We can decide when to pull them to.
Exactly. This, I'm sure we still have people that have to be part of that's a big
Yeah.
They've already been moved. People who haven't touched things in like over 6 months have already been moved. As of early in the summer, we're already moved from assistant to like this. So that should be easy.
Cool. Yeah. So I think, I mean, I don't know if people are excited about doing that. I think that totally orthogonal to the Docker conversation would be like, let's clean up the machines and get them nice and shiny and running like new. And so if people are okay with it, I think I would assert, you know, let's take one down. Let's expect to take one down by the end of the semester, and let's start gradually moving stuff off. If that's
I like 100% support.
It's actually not even that many people. It's only like maybe half the lab is even using the machines, right?
Does anybody have a vote for which machine we should do it to first?
Yeah, I think.
Cloudcorn?
Okay.
Cool. So let's.
I was gonna say Blaine because it's the oldest one, but
Yeah.
Yeah.
I mean, I spent a lot of time over the summer into getting Quadcorn up to date. That's I think people are using it.
So if no one uses Quadcon, it means.
wait, I use Quadcorn.
Yeah.
Oh, set mine.
Yeah.
Thank you, Tony.
Yeah. I actually use Quadcorn quite a bit because it's the one that's least busy.
Yeah.
I'm not married to any particular server.
So this is, I mean, my proposal is this. Let's say it'll be Quadcorn, and we'll intend, like, you know, plan to have everything off of Quadcorn by January 1st, 23. Right. And we will do a, you know, early in next semester, we'll take down Quadcorn and pull it back up with maybe with network storage to Rex, latest operating system, latest everything.
But if it's only Tony, then it can even be easier. Like, no, Tony's gonna get a better computer like that runs more stably in practice. So in that sense, I think Tony can just let you know once he's ready for it.
Cool. Okay, so no one start new jobs, and I'll talk to you and Tony, and we'll take it down and polish it up and get it running again. Other questions? We only have 5 minutes left, and I hereby promise to help you all with getting stuff set up. And when we have the new machine, it's going to be really fun because it's got a lot of GPUs.
How hard is it to like walk through an example where you do like a Python install, write a quick PyCode that simulates some random data,
Yeah.
perform linear regression, then save the data externally.
Could reasonably do it in the next 5 minutes,
Okay,
maybe.
got it.
Yeah. I also have a blog post that I'm going to put up on the on the Kording Lab blog of how to set up a machine for this and how to use it exactly like that. How to like clone a GitHub repository, you know, open it up, run your code internal to the container, and then shut it down and save your data products out.
I wanted to also say that I'm so excited to deal with the lab now because like we are like the most unafraid of science.
I'm the most afraid, which is why I spend
Which
all
is
the
why
time.
you're separating software.
Yeah, exactly. Lots of
Hardware as much as you
abstraction,
can.
lots of insulation everywhere.
I think it's cool. It's a really cool idea.
I have a philosophy question.
Yeah.
As long as we're still high level for a moment. Sorry, Justin.
So that was the extent of my comment.
Well, no, sorry for your demo that you wanted.
Oh, that's right.
So you pitched this at the beginning as a solution to the problem of I installed Conda and it broke my entire system.
Mhm.
If you're a person who does not have that problem, is
Yeah.
like, to what extent are you like mandating that everyone use Docker, or are you just saying like, hey, if you've experienced these issues, here's an alternative you should
Yeah.
consider?
I would like, and Tony, let me know what your thoughts are here. I would like to gently mandate it to start and see if it's painful. And I would also say, you know, let's build a Conda image that like makes this painless. And if it's not painless, we should not continue.
I'll dab wide.
Yeah. Tony, go ahead.
Yeah, I was actually gonna say sort of exactly that. Like, so one thing that I think we'd want to decide as a lab is like like how strictly we want to enforce this. And so Jordan, I think we talked about like using Rex itself as sort of the testing ground for this exact workflow. Because like if we think about it now, the resources that we currently have in lab like are sufficient in some sense. So like we're not disrupting anyone's workflow by making Rex, Docker only in some sense, right? So I think that's probably the way to start. And if there are pain points, then we can sort of come back and reevaluate.
Yeah, I totally agree. I think maybe that's a good tentative starting point. If people are not super upset about that, is let's make Rex Docker only to start. We will find out if it's painful, and if it is overwhelmingly painful and cannot be done, then we'll dial that back. But I think at least for now, that's a good way to start and a good way to demo this out.
Yeah, sorry, if you already talked about it, but one thing that I like about Docker is that it's also like really useful for making sure the code is reproducible, like for, I don't know if there's neuro or AI conferences there, but for scale conferences, they often have like an artifact evaluation stage where you have to submit an artifact and then someone has to reproduce it on their machine. And it's not a like requirement for publication, but if you do it, you get like a nice stamp on the paper. And like I ran a piece of code from like 4,000 BC on my computer using a Docker container, and it was like pretty painless. And I thought like, wow, this would have absolutely sucked if I did not have the Docker container.
Yeah, it really is. I mean, like, when you version pin and you put stuff into an image, it really is like, well, this software is gonna run. All the libraries that it needs are in them.
Yeah, so like in sort of independent of working with the new machine really nicely, it's like a good scaling thing for having like who cares if you post your GitHub if nobody can use the code, right? So the Docker just ensures that it's really painless for someone to try to demo it.
So I'm still getting an error when I just try to run Docker.
Yeah, this is
a me thing or an everyone?
It's a you thing. I mean, it's not a you thing. It is the default configuration of Docker, and I'll set it up. What we need to do.
That's not something to set up with everyone.
We can. I mean, I think that it's probably easier. Maybe Tony and I will add everybody to the Docker user group, and then that fixes the problem.
Okay.
Yeah. People. Yeah. There's some initial setup that we should do on those servers.
Yeah, that makes sense.
Going on the reproducibility thing, that's like, is totally on brand.
Yeah. It's good. I mean, it's good science, right? It's good engineering and it's good science, right? I mean, what the trade-off is that you pay a little extra in upfront cost of like, if you already have, these weird esoteric libraries installed on your machine, you don't have to install them a second time, right? But like everyone else is going to have to install them. So I think that it's good behavior, not to mention the fact that like, probably because we are like, not really going off the rails on a lot of this stuff. There's Docker images for many of the libraries that we use already. There's Docker images for, now I didn't demo this because we did pretty light on technical work, but you can say like, I want, from Python, and then I also want from Julia, and then I also want from R, and like install all of those dependencies as prerequisites of your image, which enables you to say like, well, nobody has ever installed scikit-learn and numpy before, but there's an image for both of them, right? And I'm going to use both images at the same time.
Really breaking the ground. Docker Composes.
No, Docker Compose is another. That actually starts to get a little more into like resource allocation management and deploying multiple containers at the same time. Cool stuff. And I think I will make sure that we have Docker Compose installed on our machines because it will be useful for power users. But that's a future teaching.
Lab policy. Sorry. Possible lab policy thing. With the wiki, it needs to be very super duper clear that new people can find you or whoever's computes ours. Like, I don't know how clear that is in the wiki.
Another thing that I kind of want to do is like when we set up a user account for a new person, I kind of want to drop some readmes into the home directory that's like, here's what you need to do to get started. And I think that this will be one of those things, just in an attempt to make things like very obvious, probably have a few aliases to say like, here's a one-liner to set up a new Jupyter notebook with your home directory mounted and a bunch of things already installed.
Now I need to do
Yeah.
I was just gonna ask about prototyping. So like when you're developing code that you're trying to, are you like running that in your Docker environment, or is it like, I guess I don't know what to word it. Is it a pain in the ass to do that, or is it better to do it locally and then take a finished product and put it in Docker?
Yeah, I mean, I do my prototyping and stuff in the Docker image, and when I need to install something that I forgot to install, usually I'll rebuild the image. What you can do that's not crazy is to like have a base image that you start with, and you install stuff in it progressively, just kind of like keep the notebook on the side.
Probably doesn't take that long to rebuild it, right?
It really doesn't, especially
You can like install a requirements.
Yeah.
file, right?
Yeah.
Understand that, right?
Yeah, exactly. The other thing that you can do, and there's this process where you can like commit changes to a Docker image. The bummer about committing changes after you're already running a container is that it eliminates the standalone Docker file that tells you everything that's ever been run, right? So you get like a tarball of this image that you can run again, but there's no like reproducible text file that you can, so you can't put it in GitHub anymore. It's going to be like, 5 gigabytes of Ubuntu installed with a bunch of commands running. Okay. But it is a thing that you can do.
To Shinwei's point earlier, you can connect US to so that you're like developing the IDE for running in the Docker.
Yeah, it's also fine to say like I'm going to make like just a base Ubuntu install, and then I'm going to have like a install.sh bash file that I'm going to run, and there's nothing wrong with that. And I'll show some examples. Probably not today because I want to let everybody go, but I'll show some examples on how to like mount files from your local, your host machine versus copying files from like a GitHub repository. They say like every time this image runs, it should be using like the actual code from the code base. And so there's no point where you need to mount the volume because we're always going to need this code in there. I can talk all about that stuff a little later.
Question. This might be a stupid question. There's if I mount a directory that is on your phone.
Yeah.
And I want to call the data from the data directory.
Yeah.
And as you can see that in our service, they are like the different parents directory. And is that possible in Docker?
Yeah, so you can mount as many directories as you want, and you can also, when you mount a directory, everything that's inside of that gets mounted also. It's also fit for recursive. So you can mount several different volumes, they're called, for different directories on your machine. So I'll usually mount, I think reasonably you could expect to mount like your home directory and like the data, /data directory or something like that. And you could expect that to be, and then you have access to both of those. You can decide where they live inside of the machine. Yes.
Because that's a good idea. We should make that package for like data, like the shared data.
Yeah.
Data and stuff like that.
So what's the best way of interfacing Docker to Jupyter and Docker?
What I would recommend is, Jupyter has an official image for Jupyter notebooks. When I'm creating a new Jupyter notebook inside a Docker container, I always use their image. And it comes up and it just, it spawns in fact, it was the command that I think I ran last year. I've got our faces up here now, but I think it was something like this. Yeah, I was struggling to, this command, right? So I'm going to run interactively with access to all of my GPUs, giving the host machine port 8888, forwarding through to the containers port 8888, and then I'm going to tell, and of course, if multiple people are running, change a digit in here. And I'm going to mount the current directory that I'm in right now, which might be like my code base that I'm working on, to the working directory inside of this container, and then here's the image name that I want to run. And when I run this, in fact, let me take GPUs.
So that means that like in that you avoid running pip installs out of the Jupyter notebook.
Right. So what
them all into the Docker.
Yeah, right. So you could say like, here's Jupyter Data Science Notebook, which has, NumPy, SciPy, scikit-learn, scikit-image, Pillow, whatever already installed. But I could say in my Docker file from that, and then I'll say, pip install Conrad's library, and then I'll say, and I don't even need to overwrite commander.
Wait, you don't need to run.
Oh, I'm sorry. Yeah, I do. That was a good point. Yeah, like this. Right. And so this is like, if you have something special that's not already installed in here, like, the regular old data science.
But that means
library.
there must be a command that's starting the Jupyter server in the front.
There is.
And you can override the run and say the command command.
I believe so. If not, we can inherit the command as well.
And is there like a good standard Docker file for data science? But like,
I use this one. I use the Jupyter data science.
Oh, that is one.
Yeah.
Okay.
And you don't have to do a notebook.
and it has Posh in it
Yeah, they
and
have,
TensorFlow.
yeah, and what you can do and what I frequently
and
do,
Auto Skylum.
I'll look up hub.docker.com, and then in here, I'm gonna say, I want like torch, and my guess is there's, probably I should have looked up iTorch, right?
There's also a Lambda Labs Docker.
Yeah.
And I feel like Lambda Labs just a good job of setting up data science. And then,
Yeah.
I'm gonna get there.
Yeah, let's see.
I get that.
So, and this is, there are, official images and stuff. So, for things like, for commonly used libraries, there are, images that can be best practice. What I would recommend that we do is like together decide on like things that we all have in common and build a Kording Lab based image that we can depend upon. And we'll say like, we're going to keep it up to date. We're going to use these libraries. And if you need anything else, you can say from Kording Lab image.
Is that
No.
something you say like in the on the machine?
So I believe that anybody on Lean has access to these images. So if I do Docker images, and there's a way to namespace them, but I don't know that it's terribly important. Nobody else will need to download this data science notebook image again because it's already downloaded, right? So you already can say from Jupyter Data Science Notebook, you can say, no, this is running in the background. It's very lightweight. It doesn't cost us anything to run. So it's nice to have always running, but everybody has access to a, Jordan's Python image now, and I'll go and clean it up.
And everyone has access to none. That's awesome.
Oh yeah. The good stuff. It's a lot of,
It's a lot of
But
gigs.
how does it know which of the two nuns to wear?
yeah. So what has happened here is probably we built, and almost inevitably this was my fault. We built an image and tagged a new version of it and forgot to get rid of the old version. And I'll do cleanup. One thing that I would say is like, there's no way for us to really access this aside from image ID. Realistically, we can delete these without hurting anybody because these are not being used. So what we can do is quickly recover, we're 1, 2, yeah, whatever, 2 gigabytes of, of hard drive space.
Oh, awesome.
Cool.
I think that's pretty much time. And yeah, this will wind up on the Kording Lab blog, and it'll wind up on the recording will wind up on the YouTube. So if you want to reference any of the things we talked about, I will send you the blog post, which has a bunch of examples and sample scripts, and this video, so you can listen to me speak too fast.
Anybody have any last comments to say to the internet via YouTube?
Every Friday.
Stay chill.
We found out, asked how each other